Praga to jedno z piękniejszych miast Europy. Kojarzy się z zamkiem na Hradczanach, mostem Karola, a także, co oczywiste, pięknymi kobietami i wspaniałym piwem. Tutaj znaleźć można również siedzibę firmy Avast, producenta znanego antywirusa. Mam kilka pytań do Avasta i miejmy nadzieję, za chwilę uzyskam na nie odpowiedzi.
My name is Ondřej Vlček. I am the CTO. I've been with Avast for like 15 years already. I started as a developer, and then after a few years I took over the program management position and eventually CTO.
So you are a strong technical person that now turned more to a business line.
Correct.
Okay. As a CTO, you're probably the best guy to talk about the new features of Avast 6 that has been recently launched. Can you please give us a quick tour about the new features, and what is more important, tell us maybe what particular feature is the most important from your perspective?
Sure. So the main important feature that I think we implemented in version 6 is something that we call auto sandbox. That's basically a subtle feature on the first side that isn't very visible in the UI or is really under the hood, but is very important for us, and I think will be one of the key differentiators between Avast and the other products on the market.
Can you tell
what
us
it is?
how does it work? Yeah.
Sure. I mean, for an antivirus software, traditionally we had to make sort of binary decisions. So basically, when we are scanning a file, it was either clean or infected. Now, if the file, we called the file clean, then obviously we allowed it to run. And if it was a virus, so it was a sort of false negative, as we call it, then the computer gets infected. On the other hand, if we call a file infected, then we basically need to take some action on the file, such as quarantine it or delete it, kill the processes, etc. Now, if it's a false positive, that means that it's actually a clean file or it's a legal file, then the consequences can be pretty fatal. I mean, if it's a system file, we basically make the system unbootable or cause more harm than maybe a typical virus would cause. So for us, the auto sandbox actually brings like a third option as the potential outcome from the engine. And that is basically something in between. We say that a file is somehow suspicious, but on the other hand, it's not as strong as calling it infected in the first place. So we basically tell the user that the file looks fishy, looks suspicious, but we don't quarantine it, we don't delete it, we just tell the user to run it isolated. So doing this allows the user to usually run the file or run the program normally. You just can't do any modifications to the operating system or to the hard drive.
And
so
what kind of isolation are we speaking about? What
what
level the isolation is?
Sure. So it's the goal there is to prevent the program from doing any modifications to the hard drive. That includes files, includes registry entries, etc. Now, that isn't as simple as it sounds, because in some cases there's some inter-process communication taking place, etc. But still, we try to isolate it as reliably as possible. So that's the goal.
So the application doesn't see any content of the hardware, of the hard disk, and how does you cope with that?
The application has a read-only access to the hard drive. When it writes file, then it is actually allowed to write files, but these are written to alternate locations, so sort of virtualized locations. And then when the application closes, it all's gone. Basically, it's all deleted. I mean, that's a feature that's also present in the free product. In the paid product, we have what we call a manual or full-featured sandbox that basically does the same thing for any application that the user runs inside the sandbox. And with the manual sandbox, the user is able to actually configure whether the data is deleted after the application is closed or whether data stays, etc. With the auto sandbox, it's all deleted as soon as the application closes.
Okay, so we are speaking about some kind of virtual machine here.
Correct.
And when it comes to virtual machine, then it comes also to the terms of performance. What is the performance effect when running such an auto sandbox feature?
In general, the sandboxed applications run almost at full speed. That's mainly because there is no emulation layer. It's really executing on the real CPU, real API calls, etc. So the virtualization layer is relatively thin compared to other approaches. On the other hand, some of the operations, that especially those that are heavily virtualized, have some performance penalties, but fortunately most applications don't exercise these APIs or these interfaces that heavily, so that the overall impact of of running the application inside the sandbox is quite small. So yeah, I mean typically with the manual browser, with the manual sandbox, we have people running their internet browsers inside the sandbox all the time with no noticeable performance penalties.
Do you use technologies like Intel VT or hardware-assisted virtualization?
No, that's a different level. I mean, these technologies were created for like a full OS virtualization, such as VMware, virtual PC, etc. This approach is slightly different because it's not like OS inside of OS. It's more like partitioning the host OS. So basically, you create a virtual partition inside the same OS, so you don't have to boot the extra OS, etc. It's like switching to the sandbox is instantaneous. I mean, you don't have to boot anything.
Okay. So the sandbox is obviously one of the most interesting things. What else do we have?
What else? So besides the sandbox, we have a new module that we call WebRep. That is short for Web Reputation Component. That's also in both free and paid versions of Avast. Now, this is technically it's a browser add-on. Currently, it works with Internet Explorer and Firefox. And the add-on basically provides the user with some security rating of sites that they visit. So whenever a user visits a site, it's got a clean markup that rates the site, and besides the overall rating, also provides some content categorization. We basically try to keep it simple, so we only have 10 categories, unlike some of the competitors that have like 100 categories, which are very difficult to navigate. So we have 10 basic categories. The data that is behind this comes from two sources. One source is our virus lab, because obviously we see a lot of malware, malware-related information from various sites. So that's one part of the data feed. The other part is community voting. So we basically rely on our huge user base to provide us with some overall ratings and the content categorization. Now, the community part we don't quite consider as a hardcore security feature, because we don't want to rely on our users to tell us whether a given site is infected or there's a virus or a malicious script, etc. That's what we are good at. But on the other hand, we think that our users are very good at telling us whether this shopping site, for example, they made a good experience there, it's got a good reputation or not, and also the categorization. I mean, whether it's a site, a news site or shopping site or not. So we ask our users to actively participate in this. So that's another feature. Now, besides these two, we have one other feature, new in version 6. That is only in the paid versions. The new feature is called Safe Zone. Internally, it is also based on the sandboxing technology, but the purpose is a little bit different. So with the traditional sandbox, you basically sandbox the application that you thought was less safe than the rest of the OS, such as the browser that could be potentially compromised or some potentially suspicious programs, etc. With Safe Zone, it's actually vice versa. The safe zone gives you a clean environment where you can run your trusted applications. Typically, applications like online banking or online shopping. So ideally, you would use the safe zone to do all your online transactions, financial transactions. The benefit here, there are multiple benefits actually. One of them is that the clean desktop, the safe zone desktop is isolated from the rest. So even if you have, for example, a keylogger or some kind of spyware running in your browser or in the normal operating system, it can't really see what's happening inside the safe zone. Besides that, the safe zone browser, the safe zone contains a special browser that we ship with the product that's based on Chromium. Is locked down actually, so it doesn't support extensions, etc. It's really like a clean browser that has very, very little potential of getting some spyware in it or some malware.
That's interesting. You mentioned it's based on Chromium.
It's based on
And
Chromium.
you don't support Chrome
with WebRep.
WebRep
support.
Are you working on that?
Absolutely. WebRep support for Chrome is coming in a few weeks.
That's great news because I'm personally a Chrome user, so
Yes, me too.
that interests me the most. Okay.
The other thing I wanted to add with SafeZone, besides the Chromium, it also provides a secure DNS channel. So we don't really rely on the operating system DNS stack. So whenever we do a DNS query, we actually do it using a secure channel to our own DNS servers.
Okay.
So we completely bypass the user's DNS settings as well as the ISP of the user, which is very important because a lot of today's malware uses what we call DNS poisoning. It basically redirects either locally in terms of some host file hijacking, etc., or even remotely, basically faking the results of DNS queries and redirecting users to a different target. So by providing our own trusted DNS service for the SafeZone browser, we really are raising the bar we make it much harder for the attacker to actually fake banking sites, etc.
Aren't you afraid about the latency issues when you're providing users with your own DNS?
Not really. I mean, we've been doing some testing with our community even before the launch, and we think that our DNS servers that are geographically distributed all over the world are doing very good job. With not really no performance penalties or so I'd say it's a very
okay. So now can we talk more about what are you doing here in your office in Prague? I mean, you have a pretty big virus lab here. And can you please tell us how do you actually discover new threats? How do you analyze them? What techniques do you use? And
Sure. So our virus lab is actually only about 30 people, so I wouldn't call it big. The thing is, we don't quite think that headcount is the key number. The key number is the number of detections, number of viruses, obviously, that we are able to detect. I mean, if we had some ingenious technology that would allow us to do it in one person, then that would be even better. But that brings me to the other question that you had: how do we get samples or how do we process them? And that's very interesting, actually. The number one source of samples for us is the user base, actually. We really take advantage of the huge amount of users that we have currently. It's about 125 million active users, not registered, not installs, but active users who actually pull virus updates. And these are spread all over the world. And all of these users, or at least a majority of them, have opted in to become part of the Avast community, what we call Avast community. What this means is that these users run some kind of sensors on their machines, and whenever we see something suspicious going on those machines, we actually are able to report that information, maybe together with the samples themselves, to our backend infrastructure. So that's what we do, and this is our number one source of new samples. We obviously don't don't do this for samples that we already detect. So these are fresh samples that we don't detect. And this way we are getting tens of thousands of new samples every day.
Are you exchanging them with
yeah.
AV vendors?
I mean, that's the more traditional way of getting samples. The sample exchange program is something that has been around for maybe 15, 20 years. This is actually how it worked back in the early 90s, where there were just a few AV companies, and this was the way it was done. I mean, what I'm seeing recently during the last year or two, a sort of revival of this system. I mean, 5 years ago it was almost that no one was exchanging. It was much more competitive than it is now. Now I see more cooperation between the AV companies, maybe realizing that eventually what counts is the overall security of the ecosystem, or I mean, for the users it's important. But still, these exchanges are somewhat slower in terms of reaction times than the data that we actually get from. Typically, the sample exchange now is once a day, whereas the data feed that we get from our user base is basically continuous. I mean, there's zero latencies. Yeah.
Okay, so let's suppose we have a sample, and then you have to analyze it and check if it's really a virus or something not a virus.
So all the samples that come here first run through some filters, basically some scripts and some programs that we have developed in-house. And for the majority of samples, we are able to generate definitions for detection automatically without having to have a human virus analyst look at these samples. Now, it's not like we are doing some MD5s or something. I mean, these are more generic detections. We always try to prefer generic detections over like specific signatures or specific hashes for obvious reasons. And so, I mean, these tools, these scripts are usually able to cover maybe 80% of all the samples that we see. Now, for the rest, we have a team of analysts, about 30 people currently, that basically their job is to look at these samples. First, we try to cluster the samples. So, for example, one of today's biggest challenges is to somehow group samples. So, for example, you have 1,000 samples, and 300 of them are coming from the same source. I don't mean same URL, but same author, basically. Originally, they were compiled using the same or very similar source code. Basically, they have the same author. But after that, they were mutated or modified in many ways. So from the outside, these samples looked completely different. But there are some ways to actually match them with each other. I mean, one way could be some kind of behavior signatures, so that the behavior of the samples is very, very similar. Others may be using some kind of normalization or canonization, basically somehow decrypts or decompresses these files so that they can be matched with each other. So that's a big challenge. We have a few people here who work on, we call this clustering, basically looking for clusters of samples that look alike, even though from the outside they look completely different. And ultimately we want these samples to be detected by the same definition or same algorithm, because that allows us to detect not only the 300 that we have already here, but also the 10,000 that are still circulating among the users, and we will probably never see.
And I heard that you have some kind of server farms around the world.
Yes.
And this is where you analyze, this is where you run these scripts?
No, I mean, the internal tools, everything is run here on the hardware that is physically located here in Prague. Now, the server farms you are talking about are customer-facing systems, basically. So that includes our updating servers. There's a few hundred of them, web servers, and obviously some e-commerce servers. And these are mostly located in the US and in Germany.
Okay. Can you tell us one more thing for the finish? What data do you collect from your users? I know that there is a web rep, there is a sample collection program, and can you tell us what do you collect, when do you collect, and what do you do with it?
Sure.
Because there are many concerns about the privacy and such things.
Okay, so I'll start with the malware collection. So as I said, malware collection basically kicks in whenever we see something suspicious. At this moment, we typically don't transfer the sample because it's quite likely that we have it already. But what we are explicitly looking for is contextual information, because I mean the sample itself isn't that interesting. What's more interesting is the URL it's coming from, is the referring URL which the user visited before this specific URL. Because typically how it works is that you have a redirect. So you visit a site that got hacked and you get redirected to the malware distribution site where you get the shell code actually. But we are also interested in the hacked sites because it's much more efficient to block them at this level than the actual malware distribution site. So what we transfer is a chain of visits that happened before the actual malware attack or download.
And you transfer it automatically, or user has to opt in for the...
That's if the user is part of the user community, the avast community, this is typically transferred automatically. If the user isn't part of the community, from time to time we ask him to send it. Okay. We recently updated our end-user license agreements. Version 6 user agreements have it all, so you can actually read through it. It has all the details when it's transferred and what it means and what exactly we transfer. Now with WebRap, that's a very good question. WebRap is a service that is based in the cloud, so it doesn't have any local databases. Then obviously we have to make the queries for the reputation of the sites. Also, when the user votes, so wants to cast a vote, then we need to transfer the information about the vote. That's quite clear. The promise that we give it, we don't match this information with any personal information or identifiable information. So that's WebRap. Besides malware distribution and WebRap, I don't think we transfer anything. We, after each successful update of virus definitions, we transfer statistical information, how many bytes were downloaded, how long it took, and which country it was from. That is simply for planning of our server-side infrastructure, because you can imagine that with 125 million users, it's a quite heavy thing.
It is. We host our binaries as the reprogrammer software to download, so I know how to do that. Okay, so thank you very much for a nice conversation.
Thank you.
Have a nice day.
Thank you.